Lesson 3, topic two-step inequalities, learning target. I can write, solve, and graph two-step inequalities for real-world situations. We're just going to jump right in. Daniel has $25 to spend at the fair. If the admission to the fair is $4 and the rides cost $1.50 each, what is the greatest number of rides Daniel can go on? First thing we need to do is write an inequality that represents Daniel's situation. So let's go read that situation one more time. Daniel had $25 to spend at the fair. So that means he can spend no more than $25. So he could spend less than $25 and he could spend exactly $25. So we're going to put less than or equal to 25 because that's the total amount he can spend. He doesn't have to spend all $25, but he can. If the admission to the fair is $4, that means right away he's going to spend $4. So we put $4. And then in addition to that, he's going to go on some rides. So we're going to add to that $1.50 each. What we don't know is the number of rides that Daniel can go on, so that's when we need a variable. We can give it any variable, so I'm going to assign that x. So we have 150x. And now we have an inequality that we can solve. So to solve that, we're going to start with undoing the addition and subtraction. So be careful on this because this is multiplication, 150x. So we're not going to subtract that. We're going to subtract the 4 from both sides. And then we are left with 150x is less than or equal to 25 minus 4 is 21. So we did step 1. Step 2 is undo multiplication and division. 150x is multiplication. We undo that with division. So we divide both sides by 150. We get x. We keep the sign the same, is less than or equal to, and then we just have to do 21 divided by 150, which is 14. So what this means is that he could ride at least at most 14 rides, excuse me. So he could ride 14 rides or 1 ride, but he can't ride any more than 14 rides. So we would graph that as 14, 13 on the left, 15 on the right. It'd be a closed circle at 14, and then we graph and shade to the left. All right, one last example for you guys. The 7th grade class is putting on a variety show to raise money. It costs $700 to rent the banquet hall that they are going to use. If they charge $15 for each ticket, how many tickets do they need to sell in order to raise at least $1,000? So what we don't know is how many tickets they're going to sell. So our variable x is going to be the number of tickets that they need to sell. So let's write that inequality to represent the situation. So we know they're going to charge $15 for each ticket. So we can do 15 times x. But then before they make the money, they had to spend money. They spent $700 to rent the banquet hall. So that's going to be negative money or subtraction. So we're just going to subtract $700 from that because they're going to have to use that money to pay for the banquet hall. And then they want to raise at least $1,000. So at least means we want to, bare minimum, raise $1,000. So we want to be greater than or equal to $1,000. So now we just have to solve this inequality. So we're going to start with that undo addition and subtraction. We have subtraction, so we're going to undo that with addition. Add 700 to both sides. We have 15x is greater than or equal to 1,000 plus 700 is 1,700. Next thing is to undo multiplication and division. We have 15x, which is multiplication, so we're going to divide by 15 on both sides. And we get x is greater than or equal to, we do 1,700 divided by 15. We get 113.3. Now, we have to ask ourselves, does a decimal make sense in this situation? And if we look at what our variable stands for, tickets to sell, we can't sell a portion of a ticket. We can't sell a third of a ticket or half of a ticket. So we would have to round this number up. So we would need to make it x is greater than or equal to 114. We would need to sell at least 114 tickets in order to reach their goal of raising $1,000. So we'd put 114 in the middle, 115 on the right, 113 on the left. Close that circle and shade to the right, and that would be how we solve and graph that inequality. That's all the notes I have for you. Go ahead and move into your practice.